So let's solve some problems. Okay. So see here, problem number 1. So see how is the problem. A horizontal pipeline carries water in a streamlined flow. Write with me. At a point along the pipe, where the cross-sectional area is where the cross-sectional area is 10 centimeters square. The velocity of water is 1 meter per second, and the pressure is 2000 Pascal. What is the pressure at another section where the cross-sectional area is 5 centimeters square. Now see here, you have 2 pipes, something like this. One is small one is big one. Okay. Something like this. And through this, liquid is flowing. That is in streamlined flow. Okay. Now here cross-sectional area is how much? 10 centimeters square. Here it is 5 centimeters square. And here P1 is equal to, this is A1 we will say, P1 is equal to 1 meter per second. And here V2 we don't know. And also here they have given pressure P1 which is equal to 2000 Pascal. So what What he is asking, P2 also he is asking you. Yes, no? Okay, how to do now this? I'm giving you a hint. First of all, you use equation of continuity. Yes. So what is that? From equation of continuity, A1 P1 is equal to A2 P2. So from this you will get P2. And then you can use Bernoulli's principle. This is for horizontal pipe. Horizontal pipe you have H1 is equal to H2, no. So that's why I'm not going to take any potential energy per unit volume. So that's why what you will get, P1 plus half rho V1 square is equal to P2 plus half rho P2 square. And here density of water, you take 1000 kg per meter cube. Okay, can you do it now? Can you do it? Yes, no, can you do it?
Yes, sir.
Do it yourself and tell me the answer. So if you will solve this, I'm writing here answer. This V2. Answer, this V2 is equal to 2 meter per second and P2 is equal to 500 Pascal. Check yourself. Okay. Yes, you can do it yourself now. Yes. So let's move ahead. Next question. This is also based on Bernoulli's theorem and equation of continuity. So see the problem. Write with me only. A liquid of density (1200 kilogram per meter cube) flowing steadily in a tube of varying cross section. In a tube of varying cross section. The cross section at a point the cross section at point A is 1 centimeter square, and that of B is 20 millimeters square. Okay. 20 millimeters square here. The points A and B, the points A and B are in the same horizontal plane. If speed of liquid at A is 10 centimeter per second, calculate the difference in pressure at A and B. Now, how to do this problem? I will give hint. You can do it later. Now, this is not water. Okay. So again, you have a pipe whose area of cross section is different, something like this. Okay. So if I am taking A1, what is given, you see, A1 is equal to 1 centimeter square, which is equal to 1 into 10 to the power minus 2 meter whole square. This is how much? 10 power minus 4 meter square. Check it. Is it right? Okay. Next one. A2 is given 20 millimeter square. So this is 20 into this millimeter means how much? 10 power minus 3 meter whole square. So this is 20 into 10 to the power minus 6 meter square. Yes, no? Check it once. Is it correct? Yes.
Yes, sir.
No. So shall I take this point as a A1 or A point? Yes. And I am taking here this point as a B. Now here you have, let us suppose, velocity V1, area of cross section A1, point A and area of cross section A1. This is velocity V2 and area of cross section is what? A2. Yes, no? Now what I am doing, density of liquid also they have given. So density of liquid is 1200, which is not water. So 1200 kg per meter cube. Now see, 1 centimeter square is equal to 1 into 10 to the power minus 2 meter whole square, 10 power minus 4 meter square, and this is A2, 20 into 10 to the power minus 3 whole square, 20 into 10 to the power minus 6 meter square. Rho L is also there. Now see, first we don't know V2, yes, no? V2 we don't know. So first you can, V1 they have given, na? So V1 is how much today? It is 10 centimeter per second, no? Yes. So this is 10 centimeter per second. This is 10 into 10 to the power minus 2 meter per second. Yes. Okay. So now you first use A1 V1 is equal to A2 V2, and therefore V2 is equal to A1 V1 divided by A2. So from this you will get V2, and after that you can use Bernoulli's theorem for horizontal pipe again. For horizontal pipe, okay. I think from here onwards you can go ahead. So what you will get, P1 plus half rho P1 square is equal to P2 plus half rho P2 square, and then P1 minus P2 we want. So P1 minus P2 is equal to half rho P2 square minus half rho P1 square. And you can take this half rho common. P2 square minus P1 square. This is what your pressure difference. Go ahead now. Yes, yes. Ashwit, your answer is right. Yes, Anirudh, right. Yes, Akhilesh, right. Yes. Yes, right. Do it now. Go ahead and complete it. Do it yourself. First note down systematically and do it. So answer for this P2, if you will substitute, is 0.5 meter per second. And this answer, P1 minus P2,
144.
144 Pascal. Okay, note down fast. Note down. Everyone finished? Yes. Okay. So let's move ahead. Now one applicative problem which is important. See here how it is. A tank is filled with two immiscible immiscible means,
Cannot mix.
yes, the liquids which cannot mix. Okay.
Sir, it will not mix, huh? And okay.
Liquids of density two rho and rho, each of height h. Each of height h. Two holes are made to the side wall at h by 2 and 3h by 2 from upper surface of the liquid. Then find the ratio of velocity. Then find ratio of velocity of efflux of the liquids through the holes. Okay. So see, this is little bit different. Let me explain. Try to understand, this is little bit different because here directly by using Torricelli's law, whatever you are getting and how we are getting, that is what you have to see here. Okay. Because if you are using Bernoulli's equation, what difference you are getting, that is what I want to show you, because these two liquids are different. Okay, having different density. This is first liquid and this is another liquid. Okay. Now each liquid is filled with height h. है ना? This is also h, and here also h. Okay. Now let the velocity of efflux from upper hole is v1, from bottom hole is v2. Now first you see in the question what they have given. A tank is filled with two immiscible liquids. So above one is having, let us suppose, density rho, and down one is having density 2 rho. And they have given two holes are made to the side wall at h by 2 and 3h by 2 from upper surface. Means what? This hole is at height h by 2 and this hole is at height 3h by 2 from upper surface only. Yes, no? Is that clear? Right. Okay. Now how to do this? See how I am using Bernoulli's theorem now. First of all, what I am doing, I am finding V1. Using Bernoulli's equation. Listen carefully. Assuming pressure same here and here, okay. So P plus rho G h by 2 is equal to P plus half rho P1 square. This P and this P will get cancelled. Then you are getting rho G h by 2 is equal to half, if pressure energy per unit volume is same, then potential energy is nothing to convert into kinetic energy per unit volume. Yes, no? This is also potential energy per unit volume. This is kinetic energy per unit volume. Half rho P1 square. This rho and this rho will get cancelled. And now this by 2 and this by 2 also cancel. So what we are getting? We are getting P1 square is equal to G into H, and therefore V1 is equal to under root of GH. Okay. Any doubt here? Understood? Now similarly, what I am doing for V2, similarly, to find V2, again let's use Bernoulli's equation. P plus rho GH plus 2 rho into G H by 2. So first pressure due to this above liquid, that's why rho GH you are getting, plus 2 rho, this is density for this liquid, into G, and this hole is at H by 2 only. Yes, no? Here. Here. Next, this is equal to half into 2 rho into V2 square plus this P. So this P and this P is cancelled. So what we are getting, see, rho G's I am taking common, this 2 and this 2 cancel. So rho G's plus rho GH, 2 rho GH is equal to this 2 and this 2 again cancel. Rho P2 square, this row and this row you cancel. And you are getting P2 square is equal to 2GH, and therefore P2 is equal to under root 2GH. What he is asking you? He is asking you find the ratio of velocities. This is equation number 1, and let this is equation number 2.
Is to
So
is to
from 1 and 2, what we have to find? V1 by V2. What we will get, Ray? Tell me. Yes. What we will get?
root 2.
Huh?
1 by root 2.
Yes. So here you are getting 1 by root 2. Okay. Note down this. Note down. So we will stop here. Okay. I will upload this video. Okay.
Okay, sir. Thank you, sir.
Thank you, sir.
Bye. Bye.